Awesome. Hello, everybody. Welcome back to session number 4 of Concordium Educate Series. Joined again by Dragos and Doris. And then we have a new guest today. We have Jody from Aryze joining later. He's the CTO there, and he's going to be hopping on for about 5-10 minutes at the end. As always, guys, let's get to the chat going. Let us know where you're calling from, and then we can see how properly global this Educate Series has gone. And yeah, okay, I'll pop back with any other questions you guys might have and clear things up at the end. But for now, I shall hand over to Dragos, who can kick things off.
Hello, everyone. Welcome to the first installment of the Concordium Educate series. So in the first parts, we've talked about the identity layer. We've done an intro to Concordium overall, and then we discussed verify and access as a solution. Now we'll get to the payment side of things. So we'll actually discuss about protocol level tokens, which are Concordium's implementation of stablecoins. I will be joined again by my colleague Doris, and we'll also have a special guest at the end. All right. Now, what we're going to cover today, for part 1, I'll be doing a little bit of an overview. We'll talk about the problem with smart contract tokens as we see it, Concordium's answer, PLT operations, issuance and governance, the ecosystem today, so issuers and currencies. And then for part 2, we will be doing a technical deep dive. This will be an SDK overview and CLI operations. We'll talk about PLTs in verify and pay flows, and it will be a demo of an allow list manager faucet app shortly. At the end, it will be an issuer's perspective where an actual stablecoin issuers will talk about PLTs. Now, the problem with smart contract tokens. So ERC20 and similar standards always rely on custom smart contract code per token. Even though that has some advantages, overall, that means that every line of code equals a potential vulnerability. So, for example, we have reentrancy vulnerabilities, honeypots, and hidden mint functions, just to name a few. Then we also have high gas cost paired on with that, because this is code we're talking about, and as a bunch of you are developers, I'm sure you know that no code is perfect. It will mean that gas costs will vary a lot, and in some edge cases or scenario, it could be way higher than expected. On top of that, there is no built-in compliance. So what happens is that usually stablecoin issuers have to bolt on compliance control after the fact. So things such as KYC, for example. The cost of smart contract vulnerabilities. So in the past years, there have been actual billions lost in smart contract exploits across the industry. So in 2025 alone, over $2 billion were stolen. As a few examples, Cetus lost around 223 million from a single integer overflow. Yearn Finance, which was audited and battle tested for years, lost 9 million because of an attacker found an edge case in share calculation math. Core Protocol lost $12 million because the dev team treated all ERC20 tokens the same way, whereas in that case, liquid staking derivatives work differently. And quite a famous one, Balancer lost around 100 million just from rounding errors. Now, the thing is, these aren't small teams making rookie mistakes. We're not talking about just a developer here building a meme coin and then having errors in the code. These are battle-tested teams. These are big companies, because you can't protect every vulnerability in a smart contract. This leads to the fact that every custom smart contract is a fresh new attack surface. The goal of protocol level tokens is to eliminate this by moving the entire logic to the protocol layer. All right. Thing is, there is no built-in compliance in the current ecosystem. So smart contract tokens have no native compliance tooling. This means that issuers must patch in allow list, deny list, and know your customer checks per every contract. At the same time, this also means that there will be different implementation per issuers. This will lead to inconsistency and fragmentation in the actual implementation and in what's live in the market. There is no protocol level connection between token operations and identity verification. So if you want to do KYC, the protocol is kept completely separate, and that all has to be done by the issuer for each specific token for each specific smart contract after the fact. This is all coupled with the fact that regulatory pressure is increasing worldwide. So we have the MiCA Act, the Digital Operational Resilience Act, DORA for short, the Age Verification Acts, just to name a few. And patching compliance into each contract is not a scalable solution. Now, Concordium's answer are protocol level tokens. These are stablecoins issued and managed natively at the protocol level, not via smart contracts. They were introduced in Protocol 9. You have a QR code there on the bottom right that leads to the CIS7 specification. So that's the Concordium interoperability standard, which specifies everything about how PLTs are built, the metadata, how they interact with the protocol. Feel free to scan the QR code and have a read. Now, the cool bit about this is that all token logic is built into the protocol itself. This means that there is a much smaller attack surface. So for an attacker wouldn't have to just find an edge case in a single smart contract. He would have to actually break the entire protocol itself. This also means that there is standardized behavior all throughout. So for all tokens issued on chain, they all have a single unique identifier and they all act in the same way. And it also leads to predictable costs. The goal of this is to, in the end, have smart money, not just smart contracts. As a comparison, overall, summing up what we've talked about so far, we have PLTs versus smart contract tokens. So the logic lives in the protocol layer, is built in the chain itself, as opposed to custom contract code, which has to be written and deployed and audited separately per token. For security, this is standardized and vetted. The entire protocol is audited, whereas each new smart contract that gets issued leads to a new attack surface. For compliance, there is actually a built-in allow list and deny list, plus an integration with the entire identity layer. So what we've discussed before with verify and access, with zero knowledge proofs, you can prove you're over 18, you can do geolocation, all whilst managing payments as well. And also the allow list and deny list are optional features. All right, transaction costs are the same. So just 1 cent pegged to the euro and predictable at scale compared to variable gas fees. For auditability, this is protocol level. So this means that it cannot be faked. There is a unique token ID for every token. Whereas when you have an ERC20 contract, for example, nothing is stopping anyone from making a copycat of the token. The last but not least important aspect which I want to mention is self-custody. So a problem that's been in the stablecoin space for the past couple of years is that tokens are held in the contract state. So they're not actually in your wallet. The goal of protocol level tokens was to always have self-custody. So the tokens will always be available in your wallet, and you as the user will always control the keys directly. Again, the goal is to have smart money in the end. This has been issued in 2025 with Protocol 9. Now let's talk a bit about how a PLT actually gets issued on chain. So we have a few steps in the issuance flow. First of all is due diligence. An issuer will apply to the Concordium Foundation. Anyone can do this through docs.concordium.com. Then the features will be configured. So we have minting, burning, allow list and deny list, plus setting a governance account. And at the end, the payload will be prepared. The final step will be an on-chain transaction. This is a special kind of transaction which will be deployed either by the governance committee or the Concordium team. It's a special transaction that has a payload attached with all of the details about every protocol level token. And at the end, live operations will be available, which means that any issuer can mint and burn and transfer and have management of the allow list and deny list, and anyone can just onboard the tokens and actually use them. The goal of this is that PLTs are for serious and regulated asset, not for meme coins, and due diligence and governance approval are required by design. Let's talk a bit about the core PLT operations. So for token management, we have the token metadata. This will be the name, the symbol, even the decimals are customizable, the description of the token, and the thumbnail and display images provided at token creation. Mint and burn are features that are usually enabled, but still they can be turned off per token. And all operations are executed at the protocol level, not as smart contract calls. Now, access control. This is an interesting bit of core operations allowed by the protocol. So an issuer, a nominated account will be able, or a nominated account by the issuer will be able to manage access control. On one hand, we have an allow list. If the allow list is enabled, it means that in order to do any transfer between two accounts, both accounts have to be in the allow list. The use cases for this would be onboarding initially. So when you actually get the stablecoins, you would be added automatically, and then you're good to go. Geofencing in case users try to use them from a restricted area, and know your customer. On the other hand, we have deny list. This means the opposite, of course. In this case, it would be even if a user is in the allow list, if the deny list is also enabled, if the account is added there, all transfers will be blocked. And the deny list will override the allow list. Now, the use cases for this are fraud, of course, sanctions, and compliance blocks. What's new on the horizon? The coming up Protocol 11 will have more fine-grained access control features where the nominated account will be able to specify admin accounts list for each operation that manages access control. So basically, this will be role-based access control that will be introduced with Protocol 11. Now, an important bit, of course, is transfers. So we have transfers with or without memo. Memo is quite useful for payment references or invoicing. This is just a small text that can be attached to any transfers. And all transfers are protocol level transaction, which means that the same finality is guaranteed, exactly the same as CCD transfers. So 4 seconds, with the fees being just 1 cent per transaction and pegged to the euro. Now, something that you will actually see in the demo that Doris will present afterwards is that PLTs allow for atomic operations. This means that several operations can be executed in a single transaction. So the demo that we presented will actually add an account to an allow list, mint 100 new tokens, and then transfer the tokens directly to the user's wallet. What this means is that all 3 operations will be executed atomically in a single transaction. So if any of them fails, the entire transaction will be reverted and none of the operations are completed in the end. So you will either have the entire process completed or it will all be reverted. Finally, let's discuss the ecosystem a little bit. So first of all, PLTs went from DevNet to mainnet in under 6 months in 2025. And live on mainnet, there are 10 stable coins for 5 currencies from 3 regulated issuers. So we have Stabler, Aryze, and VNX, and you will actually get to hear from Aryze at the end of this workshop. And these are all live on mainnet. Now, an important bit about this will be self-custody, and at this point I will pass on to Doris, and this has been the overview. Thank you.
Yeah, thanks, Dragos. Let me share my screen. Okay, you should be able to see my screen.
Yep.
I will continue here from self-custody. So I think one very important part is to understand is self-custody by design. So these PLTs that we have in the wallets, they are held in the account that the user controls. So like your account keys control the PLTs at all time. And what this means is that, for example, if you have a stable coin that's yield bearing, the account will continue to receive these rewards. That's quite different to like a lot of smart contract protocols. If you transfer your token on a smart contract, then the smart contract account is holding the kind of PLTs, or like it wouldn't be called PLTs, but tokens. In that case, like the smart contract account would own these yields. So by designing in the way that the PLTs will always stay on the account, you will continue to like get these rewards from yield bearing tokens. And for a lot of these financial kind of products, it's quite important to define and be aware of the self-custody, that it's an important compliance issue. And we think that this design will help to kind of achieve this self-custody better. And when we compare this like with ERC20 tokens that you know probably from the Ethereum ecosystem, there it's like often this case that like you don't have your self-custody anymore once you transmit the token over to a smart contract. If there's a hack in the smart contract, you might lose the tokens easier. Now the next parts will I will try to combine the previous workshops that we had about identity layers, about CK proofs with PLTs, and try to show you how these two things work together. So in Concordium, we have this identity layer, which is quite unique. And each wallet has, for example, each crypto wallet has also real world identities behind it. So think about your passport is in the wallet. And you generate CK proofs about these accounts or identities you hold in your wallet. And at the same time, you also use these PLT operations. And what it means is that you can, for example, on workshop 3, we had this verify and access where we showed, okay, you show up CK proof about your identity in the wallet, and in then the kind of workshop, what kind of the website gives you access to the website. So, for example, most common example was to show you're older than 18 years old, and then you got access to the website. With PLTs, we call it the new flow verify and pay. And in that case, it's so that you first usually generate a CK prove something about yourself. And once you have proven that on a specific account where an identity is behind it, you can then pay with PLTs. So that means the PLTs or the transaction on chain has been done on a basis that something has been verified beforehand, and you can be sure about it. So for example, sometimes could be that you prove that you're older than 18 years old, and if you verify and successfully that, then a merchant would allow you to kind of pay for maybe wine that you're buying on a website. And these two concepts, we call them like verify and access if there's no payment involved, and if there's a payment involved, we call it verify and pay. And we think that's a quite common flow that we will see much more in the future when PLTs and in general CK proof will take off. And yeah, to kind of remind you again, like payments are anonymous on chain. That means it's not that like the CK things that you prove that they are written anyway on chain. It's really just between you and the merchant that these CK proofs are kind of exchanged. They're not written on chain. But there's something on chain which cryptographically links your wallet to the identity behind it, and then that's why you're allowed, or why you can be able to generate these CK proofs. And the idea is that it should be like a one-click experience for the user, that you verify and pay, and it becomes very seamlessly. This verify and pay flow, I have an overview here, like a diagram how this will look like. And we have the user, they connect to a website. Often there's first a verify kind of step. That's the first step you do. For example, you prove that you're older than 18 years old. No personal identifiable information will be written on chain or will be revealed. Only the CK bit kind of that you want to reveal. So for example, you reveal that you're over than 18 years old, but you don't reveal your date of birth. Then a second step usually is this PLT payment or PLT operation. Often it's like something transferring, for example, a stable coin to the merchant if you're buying something. And what it means for the merchant has identified you based on whatever kind of requirements they have in terms of KYC or whatever the requirements are, and they receive the payment on chain as a PLT, for example. And the blockchain records these audit anchors. I think we talked about it in workshop 3. If you want to learn more about it, then I would recommend you to watch the workshop 3. There's specific transaction on chain done, so you can audit the whole process and people can be sure that verification has been done. The demo that I want to show you, it's about an allow list demo. And what it will show you, it's first it will do a CK proof about some attributes that you have in the identity that's in your wallet. And once you verify that, like it means once you fulfill the requirement, in the second step, you will transmit some PLTs. And the kind of CK proof we will show, it's called attribute and set. So we will prove that you're part of the European Union, or we will prove that your country of residence is in the European Union. And attribute and set means that you prove that your country is in the set of the European Union countries. And an example would be, for example, that you have a regulated euro stablecoin, and it requires you to verify first that the person that you want to send the stablecoins to is actually part of the European Union, or like residing there. And this is kind of the flows we can implement on Concordium and verify that. This is the allow list demo. I will show it in live in a bit. And yeah, the most important thing is that you can connect your wallets. Here's some information about the wallets and if it's already on the allow list or not on the allow list. And here will the things happen. I will explain it a bit once I open the website. Okay, maybe I show it first and we go a little bit through the flow, what happens here. So that's the allow list demo that we have. It's open, so you can just use this URL and visit it and play around with it. So you can either connect a mobile wallet and use a Wallet Connect, or in this case, we use the browser wallet. So I have a browser wallet installed. You can connect it. You see the wallet addresses here. And so far, my wallet address has no PLT, so there's no PLT here at the bottom. It's only CCD. And you also see that we are not on the allow list yet. And we have a balance of 0 stable tokens. So what will happen now if I click this verify nationality and get the stable coin? So the first thing is like the first step here, it will generate a CK proof and prove that I'm residing in the European Union. And this proof will then send me to backends and that it's verified. And once it's verified, because I'm from the European Union, these 3 operations will be done atomically. So that's, I think, what Dragos told you already, that token operation can be batched together in just one transaction. So what happens is then the backend sends a transaction. It adds my account to the allow list. Once I'm on the allow list, the backend can mint 100 new tokens and transfer it to my wallet, and my wallet will be able to hold it. If I wouldn't be on the allow list, this whole thing would revert, and none of the 3 operations would be able to execute. So let's click here, and we see like the wallet asks like about the nationality. Are you from the European Union? And it gives you more information that you actually proved it. Your country is one of the following countries which are the European Union. So once I've approved it, you see that the proof has verified. Here it will a little bit take some time. And in a few seconds, you will see that we have the stable coins in our balance. So let's close it. So you see that we were added to the allow list, tokens were minted, tokens were transferred, and our balance is now 100 stable coins. And you also get a transaction hash that you can check out on our Block Explorer. And when you look in the wallets now, the wallet automatically recognizes if you received any PLTs, and it will show you the PLTs, and you can explore the PLTs further. So there's also information about the allow list, deny list in there, and also you can receive, send, and do more operation in there. Okay, that's the flow from the allow list demo. So the source code is also available, so you can play around with that. I will give you an overview of the architecture. So the allow list manager facet, it's a facet because we use it for people to get PLT tokens to play around with it. So in that sense, it means that everyone can just claim once some funds from the facet, and once you're on the allow list, the front end will not, or the back end will not allow you to claim a second time, so you don't run out of funds. And that's like usually a facet for people. And what the allow list manager facet does here, it has a front end, it has a back end. The back end is connected to the Concordium node, and then it connects to like the blockchain and interacts with the blockchain. The blockchain has the PLT state, so it's aware of like if you're on the allow list or not on the allow list. And what the user flow is, like we connected the wallet to the website. Then the first step was like we proven that European Union nationality, that we are eligible for the kind of receiving these tokens. Then there was one atomic transaction which batched 3 PLT operations together. This atomic transaction was sent from the backend. So that means the backend here, it has the governance account attached to it, meaning it has a key to it to be able to send transaction on chain. And once this transaction is mined successfully, then you will receive the tokens in your wallet. And it roughly takes about like 4 seconds. And yeah, important again is like this atomic transaction. It means like either all of 3 operations succeed or none of them, but not like a partial state. It's not possible. And if you want to explore the code, it's like here. There's a link to where you find the source code. In terms of developer tooling, I will show you our developer docs. What we have there, it's like, first of all, we have 3 first-class SDKs, I would say. Like we have the Web SDK, the Rust SDK, which have full support for PLTs. It means you can send, transfer them, you can mint, burn them, add to allow list, remove from the allow list. Obviously, you need to have the right key, the issuer key to do that, or the nominated account. And we do this. And the Concordium client, it's a CLI. It has also full support for various operations for these PLTs. And then here's like the example tab that you can find the source code in the hosted front end. And I will show you the PLT documentation now. So this is our developer documentation. And if you go on the left side there, we have a section about protocol level tokens. That's the talk about today. So in the first chapter, you see an overview of what it is and how it works. Then there's a section about getting started. It explains the different kind of processes, how the PLTs are issued, what it means on testnet, mainnet, and how you can explore them on ccdscan. And then the operations are more detailed. I think mainly it's like burn, mint, move, allow list, add to deny list, these kind of operation. We have also pausing and unpausing. The issuer can do that. Yeah, they're a bit more explained. And then the examples, I think that's the most important thing for you there. We get examples about the Web SDK, Rust SDK, how to operate a PLT through these SDKs. So maybe most of you are familiar with SDKs. So the Web SDK would be probably a good start to explore that. So it includes all the queries to the tokens, to get like token info, to get the PLT state information from the chain, and and events you can also like listen to, like if something was transferred or minted, burned. And then also the normal token operations are explained. Yeah, I think there's a quite good code example that you can copy and paste. Okay, then the next thing. Yeah, one thing we maybe want to show you as well is that, like, of course, if you want to explore this a little bit, you get PLT tokens through this facet I just showed you. So it's one option. But of course, if you want to play around as an issuer, what we would recommend you is to run our local stack. And the reason is because usually the PLTs are issued by a government's transaction. And of course, like, people can usually not do this on this themselves. So the way to do this is run the local stack, meaning running a local block Concordium node locally, and then being the issuer there, because then you have the keys to do these governance transactions. And I think in the first workshop, Dragos already showed you how to run the local stack, but I can show you the repo again. That's the local stack repo. And there's a Docker Compose file in it. And once you have this Docker Compose file, you can just run the command to build it up, and then you will have the chain running, and you will also have some scripts, these make PLTs, which will create a PLTs just for you, and then you can be an issuer and do all the PLT operations. But yeah, if you want to know more about the local stack, I would recommend you to watch the first workshop that we did. There they go into more details. Okay. Then here's just a few, maybe I want to give you some teasers what the future of PLTs are on Concordium. So this QR code goes to our official website, and we have a roadmap here. And I would like that you look into the first column here. I think Dragos already said that we are about to release protocol 11. It's kind of here. We are about to release protocol 11, which will have additional functionality to role-based access in terms of the PLTs. So it means, like, for example, that there will be several admins who can then be nominated by the issuer and operate these PLT tokens. But there will be also some new things coming up, like in May here and in Q3. This means protocol layer locks. So it's related to protocol layer tokens, but this is a protocol layer lock. And what it means, we will implement locks on these PLTs. And the first kind of step will be like simple locks. That means you can lock your funds and then send it to someone else. And either the tokens will be on your account locked for a while or on the receiving end locked for a while. And there will be several operations how to manipulate these locks. So you can think about time locks, but also various other versions of how these locks are manipulated. And then later in this year, we will have smart contract locks. So there will be much more customizable what these locks can do when they're going to be released and under which conditions. So look forward to these kind of additional functionalities related to locks. And they are related to PLTs. Okay. Then here's just an overview over the resources that we have. I think the most important ones would be like started PLT documentation here at the top. Then we have a setup guide that would help you to get started. Then of course the SDK examples if you want to interact with the PLT through our SDKs. And to get a demo running, you can just go to the allow list manager and play around with it. Oops, oh no, okay. Then a short recap of like the first two parts of the talk today. So first of all, we were trying to understand what is the difference between smart contract tokens, what are kind of the inherent risks to them, and why PLTs might be more secure or better to be compliant in some way because they are like standardized, vetted, and predictable. We have the cooperations on these PLTs like minting, burning, transferring, allow list, deny list. There's also pausing and unpausing for the issuer. And this helps probably into these due diligence because governments might require this kind of by design. And we have also an advantage because these designs are self-custodial. So like it means the tokens will always stay on your account wallet. You will always have control over them. And so far we have like 10 stablecoins already live on mainnet and several currencies already. And what we managed to do is like we kind of combine the identity layer with the PLTs now. So we call these flows verify and pay, and you can make use of the CK proofs and at the same time also do payments on chain using PLTs. And for developer tooling, like best would be to look at the Web SDK, Rust SDK, or our command line tools to interact with the tokens. And also check out the dApp examples if you want. Okay, here's like our contact page. So if you have any questions or you don't know how to start, like feel free to reach out. Like both of us will help you and point you to the right people. So feel free to reach out or have anything like feedback wise, you can always come to us. And the last part of this presentation will be a little bit different because we have invited somebody who has actually kind of issued these tokens on our chain. So he will be giving you an overview of why he has worked with us and what he is building with the stable coins. So please welcome Jordi from Aryze. He will give you an overview of his work. So thank you very much. It's your stage.
Thank you so much, and super cool to hear all of this great, amazing content and progress happening with Concordium. So it's a pleasure to be here. Thank you. I'm Jody. I'm both a co-founder and the CTO of Aryze, and we've been a company which has been playing with stablecoins forever. I would almost say in this space, and one of the fun parts of actually going to where customers are in the specific different chains is about every chain has their own little tweaks and nuances, and everything has to be audited and smart contract, or sometimes it's Solidity, sometimes it's in Rust, sometimes it's something else, and to kind of go in and play with Concordium and have a way to understand, what, here you actually have some contracts which has been abstracted away. You don't have to think so much about auditing these contracts, making sure that they are actually safe and sound and secure. They're actually just a form in some page. You go in and throw in a name, your ticker, and a little bit about your issuance and the different sets of tools that you need depending on which type of token you're creating. And the team is actually pretty fast. They go in and issue it for you, and you have like a full functioning token which is working with your Concordium wallet. And to be honest, that's kind of one part of the magic, which is a fence some people can have a super nice frictionless experience with. Go in and just issue a token. I actually super much love the second part of or one of the many parts, which for me is the identity layer. I feel there's identity layer where we can go in and bridge the gap between the old analog world and the new digital one, and kind of get onboarded into the Concordium blockchain through your identity, go through KYC and KYB, and actually attach people to a specific string of a lot of different random numbers and letters. And this is now representing someone. This is someone that you can go in and present. And this is John Doe, who's from here, and everything they do right now is actually as a real account, as a real person. And for now, in this product, we're now handling settlements utilizing blockchain with Concordium. And the reason we're doing it with a Concordium is because we now have this identity layer. We don't need to worry about who this person is. They can't even get into the blockchain without getting verified, and they can't even get a wallet without going through this vigorous process to kind of get onboarded. And it's a different way to build. It's a different way to kind of not think about all the edge cases and all of the nuances and all of the annoying part of blockchain, and kind of just focus on the product. So for us, usually when we have to build with a new chain, it's a lot of worries and a lot of things that we have to think about. And here with Concordium, it has actually been a pleasure to both abstract away the security of the contracts and abstract the mysterious anonymous user behind it, and just focus on the settlements. And that's something that has been a pleasure, and something that we've quite frankly or actually excitedly been happy about to partner up with Concordium and figure out what can we actually do here, and how do we actually just focus on the part we find exciting, right? So that's something as an issuer that we've been super happy about, and you guys are quite responsive, very fast at coming back when there's something, and that's not always easy when you play in this mysterious DeFi world where everyone is just like a random NFT in some Telegram chat, and then eventually you get spammed. So that's a nice feeling, and that's something that has been pretty cool. So yeah, that's a little bit from my end.
Thanks a lot, Jody.
Awesome. If you guys have any questions, then chuck them in the chat. And I don't know if there have been any that we've missed. Not yet. Okay, cool. In which case, I think we'll wrap this up. If you guys do have any questions, as always, head over to the Discord page. That means we are now, I think we're about halfway through this series now. So we've done four sessions. We've got 4 more to go. The next one is again, same time next week. That's Tuesday the 14th. And that's going to be an introduction to sponsored transactions. So yeah, well done everyone for turning up. And if you turned up every single week, then it hasn't gone unnoticed. That's a good effort from you guys. Keep it going. And then that will all go towards getting your certification at the end of this series, which you can then go ahead and share on LinkedIn, add to your CV and all this. Yeah, but let's wrap this up now and head over to Discord if you guys do have any questions. And I'm sure Dragos will share with me the slides, which I can get onto Discord as well for you guys. All right. Thank you guys for joining. And yeah, and thanks Dragos and Doris and Jody.
Thanks, everyone.
Thanks, everyone. Bye-bye.
Bye-bye.